Good morning, everyone. I am Pratap, and today I'll continue our discussions which we have done earlier. The last day, we discussed that how all the things will begin with our experience or sense perception, and how the physical reality is related to our sense perception. We discussed how can we predict the existence of the physical reality from the sense perceptions, and one thing that will be needed in that defining physical reality or to understand the physical reality is that the association property. We have to associate some systems to understand the physical reality. One of the most important systems which human discovered is the number system, which is a very powerful system. So we discussed how we uh, come to the existence and to the existence of the number systems, that when we discussed earlier that when there will be huge amount of things or like huge numbers of something, in that case, so our random distinctions process will not work. In that case we have to use the proper logic, so that is why we in human invented the number systems. And in the last day, I said that how we can associate the points on a position on a straight line, and how we can associate the numbers to the positions of the points on the straight line. So today I will try to find out what is the way that we can associate proper logical and useful systems uh, to define or to distinguish the points in the real space. Firstly, I will try to distinguish the points on a space which will be considered in an abstract manner. So we have to classify what is existing. So there are huge number of points on the or positions in space. So we took some points which satisfy the conditions that it has to lie on the straight line. So now we'll try to gather the points which are not lying on the straight line. So firstly, our process is that we'll try to include the neighboring points of the straight line and neighboring positions on the straight line. So what can we do is that we'll firstly take up positions on a straight line which can be chosen arbitrarily, and then we will choose the nearest 2 points of that point on the straight line. Nearest 2 points means two surrounding points. Both points will be in opposite side of that particular points. Okay, so we'll consider the neighboring points which will not lie on the straight line. So we'll impose a condition that that point we will only choose which will be the nearest from the considered point on the straight line out of the 3 points. So basically we'll see that this is the points we have considered, and this is another points on the straight line, and this is another point on the straight line. So out of the 3 points we'll consider these points and we'll choose which point will be the nearest points on the surrounding space. So this nearest, we'll consider this side first, and it's arbitrary, so you can consider that side also at first. So we'll consider these sides and we'll consider the points on these positions in the surrounding positions. So this is the surrounding two, these are the two surrounding points, and this is the needle points. So we'll consider that points, and out of these points we'll choose only that point which will be the nearest to the considered point on the straight line. So usually you can know that that point will be these points, that will not be these points and these points, because these points is the closest point or nearest point to the considered point with respect to the considered point. So when we'll impose this condition, then in the surrounding space we'll find up points with respect to a considered point. So when we'll get 2 points, then we'll get the ideas of directionality by joining 2 points, and we'll get that a straight line. Okay, so our task is that what we have done is that we have considered an arbitrary point on the straight line, and we wanted to extend the surrounding space to include the points in the surrounding space from the straight line. So for that arbitrary points we can get a straight line in the surroundings, and it will be usually a perpendicular line on the considered straight line. So in the same way we'll consider the another surrounding point on the straight line. And before going to the next point, I want to say that in the same fashions we will positions the point which we have done for the first straight line. So this is the straight line. We know how can we give the name by using the numbers of the points on the straight line. We'll do the same thing, same procedure will apply here, and will distinguish the points in a logical manner. In the same way, I'll consider the next point on the first straight line. First straight line means on the given straight line. So again we'll follow the same procedure and we'll get another straight line, and we'll repeat the procedure. Then we'll get a series of straight line on the given straight line. So in this way we can distinguish the points on a plane. If you try to visualize, then you can easily find out that all the points on the plane will be included here. And in the same way we'll consider any arbitrary point. And one thing is that we distribute the point in such a way is that we'll firstly go through the points on the first straight line, and then we'll choose the point where we have to stop to go to on the next perpendicular straight line. So basically we'll follow two way to go to a points on a plane. So in this way we can say there are 2 degrees of freedom. That means there are 2 freedom that we can go to the points. If we consider an arbitrary point, then we'll see that we have 2 path we have to follow. So that is why there are 2 degrees of freedom. And now we arrived on an arbitrary point on the plane. So we consider an arbitrary point on the plane, and again we'll apply the same logic. We said the same. This is a very important thing. We'll always use the same and periodic and distinguish this type of ideas when we try to understand something, when we try to classify something, or like this type of things. When we will try to do, then we will try to take the help of this type of ideas. And now the points are on that planes, so we'll consider these points. So surrounding these points there are many points on the plane. You can see that I consider these points, and surrounding these points there are huge points on the plane. And we again consider that we'll consider another points on the surrounding space. That is, this is the surrounding space. We'll consider another point on the surrounding space, and we'll try to find out that which points makes the smallest distance with the points, and that means the points which are lying on that planes. So we'll consider these points, and surrounding this point there are some points, and so basically these points will be the desired point, which will satisfy the condition that from that point this will be the points which will make the smallest distance because these points and these points and these points will make a longer distance. So that's why we'll consider these points. And in the same way we can say that we have 2 points, so we can always draw a straight line including these 2 points, and in this way we'll cover the points in the surrounding space, but all the points are not covered till now. So we'll use the same technique here, that we'll consider each point on the plane, and we'll follow the same procedure, and we'll gather the point on the straight line. So in this way we'll gather the whole of the points on the real space. So now we know, now we have to think, and then we have to imagine, and we'll gradually realize that in this situation there are 3 ways to go to the arbitrary chosen points. So in this way our real space can be considered as if it has 3 degrees of freedom for defining a points inside the space. So there are 3 ways. That is, in this way we'll first go, then on the same plane we'll go in the perpendicular way, and again we'll go to the perpendicular to the straight line. So there is one, another, and another. Sorry, this is not the, yes, there is one and another and another. So this will be the 3 way of going to arbitrary chosen points. So in this way we define an abstract geometrical space which is conceptually defined by using the logic of distinguishing the point by using the periodic idea and the same idea, and the idea of using the number system. We have done the distinctions of positions. So till now what we have done is that we make a geometrical space which is consisting of points, and we distinguished the point in a particular logical manner, so that we can now associate the number, or we can give the logical name of the points. So our nomenclature process will be done by using proper and simple logic. And so now what we will do is that we know that when we'll distinguish the points on a straight line, and when we try to associate the number with the positions on the straight line, then we have to consider a reference point as our origin, or the origin or the zero positions. So we'll consider any arbitrary positions as the origin on the straight line, and on one side of the origin we'll distribute the number in such a way that the larger number will situate at the distance positions, it compared to the smaller number will be situated at a nearer positions. And the gap which they have to maintain will be restricted by the property of symmetry, which I discussed in the last day. So in the opposite side there will be some symmetric positions, but as this is the opposite side, so we use a negation sign with the name, and so with respect to origin there will be two symmetric points, and which will be one with positive signature and another will be with negative signature, and their name will be same. So the logic is that they are in the same distance, that's why their name are same, but as they are situated in opposite direction, so they are given the different or opposite sign. And we have to extend the association in the surrounding space. So firstly we'll consider the origin on the straight line, and we'll consider the perpendicular straight line, and on the straight line we'll follow the same procedure and we'll get the associations of numbers on the perpendicular straight line which makes the origin on the same origin. And now what we will do is that we'll repeat the procedure of associating the number, just changing the positions on the first straight line. Will associate the numbers on the perpendicular straight line. So in this way if we want to go particular point, so we have to go somewhere on the first straight line, so that will be given a name, and we have to go to that straight line, so that will be given some name. So to distinguish these points, we have to say, or we have to give two name. One will be one straight line and another will be another perpendicular straight line. And if we include the point which will be in our real space, so we have to go one more direction, so there will be three names for each points. So this is the logic. We have to use the three name to distinguish one points on our straight line, on our real space. So in this way we associate three numbers to the each points on the abstract. I'll say till now it shouldn't be, we should not say that it's a real space, we should say that it's a abstract geometrical space. Till now we didn't associate the systems with reality, so that's why it should be said as a abstract geometrical space. Now I'll shift to a slightly different ideas and systems, that is real systems. Now I'll consider the ideas of space-time and how we can derive the concept and system of concept of the space-time from these ideas. Basically, we are accustomed to an abstract idea of our space, that this has done due to our experience on Earth, that we consider the space of Earth, the space surrounding the Earth, is abstract. Abstract in the sense that this is real and it will not depend on anything. So basically, when we'll gradually look at the situations to situation, we'll realize that there is no such abstract space, and we'll again go to new concept of relativeness in our ideas and in our concept, and that I'll discuss later. Now my task is to discuss how can we deal with the space and how can we analyze the properties of space. So basically, if we try to think how can we start to deal with the space, we'll gradually fall into the ideas that we have to take the help. We cannot directly analyze the property of space. What type of help we have to take is that we have to consider the object. We have to consider the rigid object, the rigid body. We have to consider a rigid body first. And then we have to consider another more rigid body. And what we will do is that we'll just keep the rigid body surrounding the rigid body A. We'll consider the rigid body B, C, D, E, F, and we'll continue the rigid body A by adding these other bodies in the surrounding space. So now we have a concrete positions to say that all other bodies are in the space of the first rigid body A. So now we can say some property of space, which is the surrounding space or space of body A. So this space is known as the reference space, space of reference or reference space of the body A. And firstly, if we take one point, not one point, if we take two object and we mark two positions on one object and we'll mark another two positions on another object, and the condition is that we'll take the two bodies at the body A and the distance between the two positions on each body are same, distances are same. So what we will do is that we'll go to the space of body A. We'll go means we'll take the body, we'll consider the body, two bodies as body 1 and body 2. We'll take the body 1 in the surrounding space of body A in an arbitrary manner, in an arbitrary rotation and arbitrary translation. We'll move the body and again we'll move the body 2 in an arbitrary manner in the space, and we'll arbitrary manner means here also the same thing, that rotation and translation, and which is permissible to the rigid body. We can use these movements or whatever you can say it. That after that what we will do is that we'll bring the two body again at a same positions on an arbitrary positions on the space. So if we do this procedure, so from different experiment or experience we can also say that these 2 points, the distance between the 2 points on the same body will be same at any position of space and any time of space. That is, everywhere and always they will be same. That means if we take arbitrary distance at a particular positions in the space of reference body A, then at every positions and every always the distance will be same. So this is one of the property of this space. So this property is known as the congruent property. So this is one of the major property of the space, and if we further analyze the property and if we look at this situation of moving two bodies, we'll again discover that this property lead to the homogeneity of space. That is, at everywhere we'll get the position, the distance as same. So this is the homogeneous property of space, which is obeyed by this space, and it is also isotropic. That means if we take the two object in one direction first, and if we we'll bring the object in one direction first, and then we'll bring the two object in another direction, and we'll reach the two different positions, and we'll see that two distance will be again correspond to each other. So this is from our experience and some experiment, we can say that the bodies of the space of reference is homogeneous and isotropic. So now one thing we can say right now is that firstly we have defined a geometrical abstract space which is known as the Euclidean space, and we now derived the idea of homogeneous and isotropic physical space of the space of reference body A. So now what we will do is that we have to understand and distinguish and define the physical systems by associating a systems which we can easily understand. So now we'll attach this abstract idea with this physical system in such a way that the both will follow the homogeneity and isotropic property, and they are actually following this. That's why we can associate the mathematical geometrical abstract systems with the physical body, and the body with respect to which we are defining the physical space will be situated at the origin. And one thing I will do for making it more convenient is that the geometrical system is made of some conceptual or imaginary line or grid. So we'll attach the rigid rod in the place of grid, and they will be considered as a real object, and and besides that they will be considered as a unit of measuring distance. So in this way we have arrived in a situation that we have a real reference frame of reference. So this is called a frame of reference, where all the positions on the real space which are occupied by the objects can be distinguished, can be defined, and they have the names, and every object which will be situated in the in the space of frame of reference, every objects or points has three names. So 3 degrees of freedoms are there. So this is the ideas of space. So what we have done is that we didn't say that actually we couldn't say that what is the property of space until we'll associate the space until we'll take the help of an ideas of associating the object within the space, and will define this associations process by proper logical way by using the abstract geometrical systems, which is made of imaginary lines and some logical distributions of points which are given three names. In this way we can deal with the systems by associating the frame of reference. And now this space is called the space of the body A, and we can talk many things of this space, that this space is homogeneous, it will follow the congruence property, and if we try to find out in this space, we can define the concept of concept of distance. Like if we consider two arbitrary positions, we know there are three names, and one way of knowing the distance between the two positions is that we have to consider the components difference. That means one freedom, we were used to tell freedom as a components, and to find out the distance we'll take the difference in components and we'll square the components difference and add up, then we'll arrive the distance square between the two positions. So this is a Pythagorean law that will be obeyed by this space of body A. And there are some other properties which we'll discuss later. And now I will shift to the idea of time, that how can we deal with the moments, or more precisely the identity of time. So I said in the last day that time is the continuations of moments of our experience. So if we have to deal with the systems, so we have to associate some logical systems to deal with the systems, which we have just done for the space. So to deal with the time, we'll again take the help of the number systems. So we'll associate the numbers with the moments. So what will be the procedure that which we can follow to distinguish or uniquely define the moments by using the number systems? We have to take the help of one complex object which has the property that it can give the count with the series of moments. It can give the series of counts to the series of moments, so which is known as the clock. So to do this, what we'll do is that we'll associate the number with the moment or time in such a way that larger number will be associated with the later time in comparison with the smaller number will be associated with the earlier time. So in this way we can distribute the number on the moments, but the distribution is not unique because we said the larger, but how larger or how smaller we didn't say. So to fix up this arbitrariness, we have to restrict and we have to imply one more condition, which is if the continuation of moment to arbitrary moments is same, then the number difference associated with each continuation of moments will be equal to each other. So in this way the gap between the number will be fixed. But what will be the exact number? So for that we have to use the reference or origin, that for a particular moment we'll consider as zero moment. We'll consider the number 0 for a particular moment, and then we'll associate the larger number with the later events. And this association can be done with the help of the clock. That clock will give the tick, 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 tick. This series it will count, and we'll compare this tick, tick, tick count. We'll compare this series of count with the number. And one condition will imply in the clock is that the duration between two tick tick in the clock will be constant. So in this way we can uniquely define the time, and we can precisely define the time by the help of the number systems and with also the help of the clock, which furnish the series of events. I will compare this with the moments. So in that context I want to say that we defined the space by using some consideration. We made a system of space and time by using some consideration, by restricting some conditions. And what can we tell apart from this? Is this space and time, what we can understand by associating this, is real? So the concept of reality will be questioned. Whom we can called as whom or which things we can call as real. So basically we are accustomed to consider those things as a real which are same to different individual. Like for that, if we experience as an individual, I can experience many things and you can experience many things, and we have limitations that we directly cannot compare our experiences between each other. But as a human we have an advantage that we can exchange our ideas or experiences by our languages to each other. And when it will appear that some out of them are same for all the persons. So that thing we are used to consider, we are accustomed to consider as a real, because this is something which is existing irrespective of our observations and our existence. So these realities are having the importance in science, and the most fundamental of them is the physics, is dealing with that common and same real things. So what I have discussed for the space and time, the concept of space and concept of time, or the systems of concept of space and time, they are real. But when we'll go further and analyze the systems with considering some other things, we'll gradually know and realize that they are real, but they are relative. So the idea is tricky, but reality is something we have to keep in mind, that reality is something which is existing irrespective of our of the existence of the observer of individuals. And thank you. Bye.